This presentation provides an introduction to the Inertial Reference System interface test procedures and indications. We will also cover fault isolation, which includes byte-detected faults, manual fault isolation, and IRU rejection criteria. The IRS interface test is a quick test to check out airplane interface integrity. An on-ground interface test of the Inertial Reference System can be initiated from the Main Equipment Center or flight deck area. To perform the interface test from the Main Equipment Center, press the test switch on the IRU's front panel. IRS self-tests cannot be initiated in flight. We'll use the left IRU to demonstrate the interface test from the Main Equipment Center. The Inertial Reference Mode panel, or IRMP, should be in the nav or align mode. The test has no effect on the IRU fault ball, which remains black. Press and hold the IRU's front panel-mounted test switch until all desired IRMP and flight deck displays have been observed. The following sequence of indications appear on the IRMP and the Captain's Electronic Attitude Director Indicator, or EADI, Electronic Horizontal Situation Indicator, or EHSI, Vertical Speed Indicator, or VSI, and on the First Officer's Radio Distance Magnetic Indicator, or RDMI. On the IRMP, these left IRU annunciators come on for approximately 2 seconds. Align, on DC, DC fail, and fault. During the same period, the IRMP's data display indicates a north-south all-eighths display for latitude and an east-west 188 degrees and 88.8 minutes for longitude. During the next 8 seconds, all left IRS mode and status annunciators return to normal. At the beginning of the interface test, the following test values appear on the Captain's indicators for approximately 2 seconds. On the VSI, minus 600 feet per minute. Note, due to scan rate differences, a slight flicker is present on the CRT display units shown in this module. It will not be present on the actual airplane displays. On the EADI, a roll angle of 45 degrees right and a pitch-up angle of 5 degrees. On the EHSI, a magnetic heading of 15 degrees and a magnetic track angle of 15 degrees. Also on the EHSI, a wind speed of 100 knots at a direction of 35 degrees magnetic. On the First Officer's RDMI, a magnetic heading of 15 degrees. 2 seconds after the start of the test, the Captain's EADI, EHSI, VSI, and the First Officer's RDMI show fault displays and flags for 8 seconds. 10 seconds after the start of the test, the Captain's EADI, EHSI, VSI, and the First Officer's RDMI displays return to the test values previously shown. The following test values are displayed on the IRMP. Track angle of 0 degrees true, and a ground speed of 200 knots. Present position of north 22 degrees, 30 minutes, and east 22 degrees, 30 minutes. Wind direction of 30 degrees true, and speed of 100 knots. True heading of 10 degrees. The test values displayed on the flight instruments and IRMP data display stay on as long as the front panel-mounted test switch is pressed. When the test switch is released, the interface test terminates and the IRS returns to normal operation. A similar test can also be performed for the right IRS. The test data displayed on the First Officer's EADI, EHSI, VSI, and the Captain's RDMI is the same. To perform an interface test of the center IRU, press either the Captain's or First Officer's IRS alternate instrument source select switch. This causes the center IRU to display its test value outputs to either the Captain's or First Officer's EADI, EHSI, VSI, and RDMI. To start the test, press the center IRU's front panel interface test switch. To perform the IRS interface test in the flight deck area, move the yaw damper test switch to the left or right position. This action places all three IRUs into the interface test during the time sequence of the yaw damper test. The test lasts about 12 seconds. Warning: check that hydraulic power is off or observe proper safety precautions. All personnel and stands must be clear of the control surfaces and the control column when the hydraulic systems are pressurized. Note: actuating the yaw damper test switch causes the rudder to move if the hydraulic systems are activated. The test displays are the same as the ones previously described, except that the EADIs show a ground speed test value of 200 knots, and the EHSIs show a magnetic track angle of 5 degrees. The test display values are only shown for a few seconds, and then normal displays are shown. Therefore, it is necessary to repeat this test several times in order to view all test displays. Now, we'll look at fault isolation. The IRS performs comprehensive self-monitoring and fault isolation tests using built-in test equipment or BITE. BITE provides fault isolation to IRS line replaceable units through tests that are automatically performed. When the IRS power is applied, a line mode is completed, and in-flight monitoring and testing is performed. IRS fault symptoms used for troubleshooting are displayed on the flight deck instruments, annunciators, ERMP, and ICAS. You should be aware of two types of faults: critical and non-critical. The non-critical faults are sometimes referred to as delayed maintenance faults. When the airplane is in the air or on the ground, an IRU BITE detected critical fault results in the following IRS fault indications. The ERMP fault annunciator is on. The IRU's fault ball is yellow. On the ICAS, a left, center, or right IRS fault message is enunciated. On the EADI, the pitch and roll attitude ball is removed and replaced with an attitude failure flag. On the EHSI, heading-related displays are removed, and the heading flag is displayed in the VOR or ILS mode. The EHSI heading bug and ADF pointers are removed in the map or plan mode, and the VSI off failure flag and the offside RDMI heading failure flag are in view. For non-critical faults, the fault ball is set to yellow, but no annunciators for the flight crew come on during the flight since usable data is still available. Minor navigational errors can occur, but no flight instrument flags are displayed. Once the airplane lands, the ERMP's fault annunciator comes on, and the left, center, or right IRS fault message is shown on the ICAS display unit. However, flight instrument flags are not displayed. Annunciators on the ERMP and equivalent messages on the ICAS reflect the power source in use for each IRU. Loss of an IRU's AC power source causes the associated ERMP on-DC annunciator to go on, and an on-DC ICAS message is displayed. This indicates that the IRU is operating normally, but powered by the 28-volt DC hot battery bus. Restoration of AC power allows the IRU to operate on AC, and the on-DC annunciation goes off. An IRS 28-volt DC hot battery bus failure causes the ERMP's left, center, or right DC fail annunciator to come on. Also, the ICAS IRS DC fail message is displayed. You can also manually perform fault isolation using the center IRU, the ERMP, the FMC CDU, or the Maintenance Control Display Panel, or MCDP. You can substitute the center IRU for a failed left or right IRU to aid in fault isolation. To accomplish this, press the captain's or first officer's IRS alternate instrument source select switch. The IRU memory stores IRS byte-detected faults in the form of numeric maintenance codes for use by shop personnel. On most ERMPs, these codes provide flight line personnel with a numeric display on the ERMP to verify faults. Codes 01 through 09 relate to critical faults. Codes 11 through 20 relate to non-critical faults. To display the maintenance codes, turn the ERMP display select switch to the heading position. Press the 0 key and then press the 1 key within 5 seconds. The highest priority maintenance code appears in the right-hand numeric display. Record this code, then press the clear key to display the next highest priority code. Repeat this procedure until the display goes blank. All the codes will then have been displayed. The display clears when the display select switch is rotated to another position or when any key on the keyboard is pressed. With the airplane on the ground, the left, center, or right critical IRU faults can also be confirmed on maintenance-related FMC CDU display pages. Calling up the Initialization Reference Index page allows you to select the Maintenance Index. Selecting the Maintenance Index provides access to 2 data pages related to IRS operation. These 2 pages are the FMC Sensor Status page and the IRS Monitor page. The IRS Monitor page will be described later. Press line select key 2 left to display the Sensor Status page. This page provides an indication of either IRS OK, Test, or Fail for the left, center, or right IRU. IRU faults can also be detected and identified by observing the flight fault displays on the MCDP. First, turn on the MCDP. Wait for the completion of the MCDP's self-test. Then press the Yes Advance switch to view possible IRU flight faults. This example shows how the MCDP faults are displayed. 01 identifies the previous flight segment. The flight deck effect is autopilot disconnect, and the cause is a center IRU fault. Pressing the flight fault switch on the MCDP when an LRU fault is displayed provides additional diagnostic codes relating to the IRU fault. The maintenance manual provides the procedures for interpreting the MCDP diagnostic codes. Some IRS faults may not produce any of the fault displays previously described and only cause excessive end-of-flight position and or ground speed errors. These types of faults are referred to as performance faults. Apply both position error and residual ground speed rejection criteria to determine whether or not performance faults are significant enough to require hardware replacements. This should be done at the end of a flight segment. First, we'll look at the position error rejection criteria. This must be applied before power shutdown and before switching out of the nav mode. Replace the IRU if the IRU actual position error exceeds the maximum allowable error on 2 consecutive flights. Obtain the actual airplane position from latitude and longitude placards at the terminal gate, the flight manual, or the FMC navigational database. To determine the maximum allowable position error, use this formula: 3 plus 3t, where t equals the number of continuous hours the IRU has been in the nav mode. To illustrate the formula, we'll assume that on the last flight, the time in the nav mode was 2 hours. Therefore, the maximum allowable position error is 9 nautical miles. The next step is to find the actual IRU position error. Press line select key 2 right to select the IRS monitor page from the CDU maintenance page index. Selecting the IRS monitor page displays the position error rate for each IRU in nautical miles per hour. Multiply this error rate by the actual flight time to get the actual position error value. Flight time is the number of hours from liftoff to flight completion or engine shutdown. To illustrate this formula, let's assume the actual flight time was 1.5 hours. If the left IRU has a position error rate of 2 nautical miles per hour, and the flight time is 1.5 hours, the actual IRU position error is 3 nautical miles. Now, compare this value with the maximum allowable position error. Since this value is less than the 9-mile maximum, the IRU is okay. Now, here is the IRS residual ground speed rejection criteria. If an IRU's residual ground speed at the end of a flight exceeds 20 knots on each of 2 consecutive flights, the IRU should be replaced. Check the residual ground speed value when the airplane is still powered and stationary and while the IRU is still in the nav mode. Set the display select switch to the track ground speed position to display residual ground speed on the ERMP for a specific IRU. Then, set the system display switch to left, center, or right IRU. The position reference page displays residual ground speed. Display this page by selecting the position initialization page on the CDU and then pressing the Next Page key. This display indicates the residual ground speed and present position latitude and longitude as computed by each IRU. The ground speed display for each IRU is retained at the end of the flight until the FMC is powered down. A faulty air data computer, or ADC, affects normal IRS operation. A faulty ADC causes an off flag to appear on the VSI if the IRU is in the nav or attitude mode. If the IRU is in the nav or attitude mode and receives an invalid altitude input from the ADC, the IRS outputs vertical speed and inertial altitude as no computed data. If the IRU is in the nav mode and receives an invalid airspeed input from the ADC, or a true airspeed less than 100 knots, the IRU outputs wind speed and direction as no computed data. The result is a blank wind display on the EHSI and the ERMP numeric display. If flags also appear on the electric altimeter and Mach airspeed indicator, the faulty component is generally the air data computer. Select the ADC alternate instrument source select switch to confirm this conclusion. If flags do not appear on these 2 other air data instruments, the problem is generally located in one of the IRUs.